Hello everyone, good morning. Thank you ARC for the opportunity. Myself Arvind and I will be presenting my invention on a smartphone annotation tool for image labeling for artificial intelligence in diabetic retinopathy. We initially began by asking doctors to annotate the images using online platform but faced some of the following issues like volume of the data increased over time and less portability because of desktop sites, long images loading time due to weak internet connections, ever-changing disease schema, and as we kept on receiving some new data from hospitals, we could not upload to these tools as it may violate patients' data privacy laws. This led us to develop our own in-house image annotation tool as seen in the video. Adding in annotations for an image is pretty easy. View the image, magnify it, change the brightness, change the contrast as needed, click on the relevant option, choose the extra details, and the annotation is saved. The analytics on the landing page shows the pending and completed images. The graph also shows the maximum number of images stacked by the other users in real time and gave the daily target settings. These imaging data sets are generally in the range of thousands and can be overwhelming for a single person. So we chunk them into sets, each containing 1,000 images or less, which a grader can complete in 2 weeks. The issues mentioned earlier were resolved as follows. For faster image loading, we resize images into smaller size thumbnails with a smaller memory footprint and still maintaining the visual quality. We leveraged the asynchronous capabilities of the browser and didn't load just one, but 3 images preemptively so that the grader doesn't need to wait for the next image to load. The initial interface was basic and it is stopped. The initial interface was basic and evolved based on the grader feedback. It is now designed on a decision tree structure to render the nested subclassification and extra options. Finally, on the developer's end, we managed to Dockerize the entire application and deploy it using the Kubernetes platform. So we have seen a total behavioral change where on the online tools, the grader used to work only on the weekend, but on our tool, we have logged users on all days of the week. Average time taken to label a single image reduced substantially. We validated the AI algorithm, developed using annotations on this tool on some new testing data sets and found them to have a really high performance score. This again strengthens our hypothesis that this tool is no different than the desktop-based tools and with added advantages of being portable and flexible. So on the basis of satisfactory levels of verification and validations, we are developing a smartphone-based app on a binary system of referable or non-referable decision for the common retinal disease. On this unique convolutional neural network-based algorithm on feeding a single retinal image, it undergoes multi-level screening to provide a diagnosis in less than a minute to decide whether referral is required or not. Also, there is a color coding to decide between a normal light green cold zone and an abnormal red hot zone, along with a specific measurement of various biomarkers like in glaucoma for referral. Hopefully very soon it will be available on Google Play Store. We wish to introduce more gamification, label optimization to be used in telemedicine with some minor tweaks. This tool can be easily adapted to work for other domains as well, such as anterior segment telemedicine, radiology, dermatology, etc. Thank you so very much.
Nice presentation. Dr. Nair, your comments, please.
Yeah, that was really nice. It's using the most important tool in our century, the smartphone. One question, how do you maintain anonymization of data? That it comes, it is graded, and it is reunited with the patient data. How is it done on the instrument?
Previously, we used the publicly available data. Right, and now we are using the data after taking the proper consent.
No, but how do you separate the patient labels, grade it, and reunite it with the patient labels on the smartphone?
I'm not, if any image is feeded, right?
No, but you have a patient data. You have to remove the patient data before it goes for grading. Yeah. And after grading, it has to be reunited with the patient data.
Yeah.
How is that done?
On cloud.
So your patient data is not secure on cloud?
Definitely means we are taking consent from the patient that it will be used.
Okay, yeah. I mean, yeah, that's fine. Second point is that how is the inter-observer variation if you use 2 quality of cell phones here?
Yeah.
A very high-end cell phone and a very ordinary cell phone. Have you noticed any difference in inter-observer variation?
No, because we have this contrast and brightness, so we can make any image. 5% of the images, they can't be graded. right? Otherwise, we have contrast in the brightness slider, so we can grade any image.
Sure. Okay.
Yeah. Thank you.
Yeah.
Thank